So, hello and welcome to the DevOps 101 webinar hosted by Clearvision. There will be two talks today. I will start with a high-level introduction to DevOps, which is aimed at the beginner's level. So if you've heard of DevOps and you've always wondered what it is, you are in the right session. And after that, Nigel will cover how tools can be used to help support and implement DevOps principles. And finally, we will wrap up with a Q&A session where we will try to answer any questions you might have. So let me kick this off with the essential question. What is DevOps? Before I start, let me just introduce myself. My name is Muschol. I'm the Technical Director here at Clearvision. And I started my career as a software developer at Philips Semiconductors 25 years ago. And over the years, I've taken on a variety of roles in both dev and ops environments. So I've been a developer, I've been an architect, I've been a development manager. And on the ops side, I've run ops and support teams. I've been a cloud architect, run teams of architects. And most recently, I became technical director here at Clearvision. So I've been on both sides of that proverbial wall, and I've felt the pain of taking that step into DevOps from both sides. So let's have a look at where we are in the world of software development and where DevOps really fits in. So there's been a big change over the last 10 years or so in the software development world, and Agile has now become the new norm. The majority of teams now report that they're using Agile, and these figures are from the State of Software Report 2016, in case you're wondering. And what this means is that all the functions within a development team now work much closer together, work together, support one another, and they have shared goals. Testers, developers, they have shared goals rather than throwing new features over the wall and hoping that testers do not find any problems. And what this has allowed software teams to do is to create value much faster and at the same time improve quality. The other thing that's been happening over the last 10 years or so is that Git has really taken off as a version control system. And what this has allowed teams to do is to experiment more in safe environments, knowing that they have a version control system that supports them by branching, merging, cherry picking other people's changes, experimenting, seeing if something works, discarding those changes and trying something else. And what's really happened is that both Agile and Git have empowered software teams and transformed the way they work. And the adoption of Agile and Git has really transformed the software world. But there are always ways we can improve. We always aim to be better. And DevOps really highlights one of those areas where we need to focus our attention now. Because we still have a problem. We still have silos within these organizations. So the development team problem of throwing stuff over the wall to testers and testers throwing it back, this is still happening in organizations even if they've adopted Agile. But it's no longer within the development teams. It's now the ops teams and the dev teams throwing stuff over the wall to each other, and customer services being sort of caught in the middle. And this doesn't really, the whole structure of this doesn't really encourage teams to work together and communicate with people outside of their little bubble. And especially software teams, they operate within their own little bubble, developing software. But at the end of the day, if it's not in front of customers, being used by customers, what does that really mean? So ops and support customer services are absolutely crucial in the overall picture of delivering software and putting it in front of customers. So Agile and Git are great prerequisites for that culture of DevOps. But there's a lot more to building a culture that allows for cross-functional teams to maximize efficiency, to work together, collaborate, to innovate together. And we really have to act now. We have to nip this problem in the bud because software is becoming so important. Software is eating the world, as they say. So it's becoming so important in all areas. And we can't let this problem hold us back. So what exactly is DevOps? I've mentioned the term a few times now. Let me try and explain this with a little story. And this story is about something that happened to me a few years ago, within the context of an organization that's pretty good with DevOps and DevOps principles. And what this really shows and illustrates is that even organizations that are good at DevOps and understand it well and practice it, they can fall into this trap. So I was heading up IT Ops, and I had a request landing in my email inbox, and it was from another senior manager, and it read, and I'm going to read this out because you know, just to help you understand it. So it went, "Hi Matt, I didn't want to distract our in-house development team from their work, so we employed an external partner to develop a solution that integrates our ordering system with Salesforce. Can you get in contact with Sarah," I've changed names here by the way, "and see what it will take to put this live? We just need you to deploy it. Trevor." So I kept reading through that message over and over again to sort of try and make sense of it, and particular that final sentence. We just need you to deploy it. So I scanned through that email trail that came with the message, and it was 70 odd emails. It was a long email trail. A lot of conversation had happened before it even landed in my inbox. And I immediately knew that we were in trouble. Where would you even begin with this? There's a live ordering system on one side with real life orders. And there's a live cloud CRM system at the other end, containing mission critical customer data. And there was an application that this person wanted my team to deploy, which integrated both of those systems and which we knew absolutely nothing about. So as you may have guessed, this is the exact opposite of DevOps. Because DevOps is a culture, and I'm going to use this word a lot. It's a culture where Dev and Ops collaborate to build a faster, more reliable release pipeline. It's about shared goals, ensuring that everyone is working together towards the same target. It's about collaboration, working together. But what does that really mean in practice? Let's drill down a little bit further. So DevOps is underpinned by three principles, or the three ways, as Gene Kim calls them in the Phoenix Project. If you haven't read the Phoenix Project, it's a fantastic book. It's a novel, and I mean a story. It's not a textbook that covers DevOps, and it's a very good read. So let me explain the three principles. That's the first one. Flow. It's about making work visible across groups, Dev and Ops and customer services. It's about limiting work in progress, reducing handoffs, and it's about resisting that urge to just blindly throw things over the fence. Because the person receiving at the other end may have no context of what you're throwing over that fence. It's about working as a system, not as a silo. Sound familiar? Agile within a development team? Now we're going across an organization. Second, amplify feedback. Aim for fast feedback. It's about catching failures before they make it downstream. It's absolutely imperative that we do that. It's about making sure that all the different stakeholders swarm across incidents as they happen. Swarming means that it's not somebody else's problem, it's our problem. We are a team, we are a system that is resolving this. And three, continuous experimentation. It's about creating a culture of learning. It's about risk-taking to a certain extent. And learning from failures is now viewed as a step forward. And it's about making daily work better through constant experimentation and open-mindedness. So, back to my story. We just need you to deploy it. Looking at the principles from that previous slide, this is the situation we are facing, right? So visibility, the ops team had no visibility or warning that this was even happening. They had no understanding of what the application did. They were not even able to assess what sort of damage it might be able to cause. 2, feedback. We had a name for someone who could help us deploy it, but we had no way of feeding anything back into the development cycle. Development had finished. It was just a question of deploying the solution and signing it off. And 3, continuous experimentation. Yes, we were experimenting, but this was ops in isolation. We had no idea what we were doing, so everything was an experiment. It was all about, let's see if this works. Because it takes a team to do DevOps. DevOps is everyone's job. When you compare that to the traditional enterprise model, where dev and ops sit on opposite sides of the fence, it's a complete culture shift. It's about making a decision to be more transparent, more understanding, and more cooperative. So there's this famous quote from the Amazon CTO: "You build it, you run it." It's not, he's not suggesting that ops teams write software, and it's not about dev teams running operations or manning the support desk. It's about ensuring that all the different functions have all the same goal, which is to build software and to run it. They all work together on this, and it's all about improving. It's working towards a singular vision and improving what we do on a daily basis, and it helps improve efficiency and quality, and ultimately it results in more satisfied customers. And the other thing that seems to happen is that it also results in more satisfied employees. So how did the story end? Well, after lots of back and forth between IT and that external partner, several conference calls, endless email threads, getting architects involved, IT involved, some internal devs with Java knowledge involved, and the third-party developers, of course, we finally managed to get the application deployed. And it was lacking some major features because no one had really thought about how it would run. There was no authentication, for example, and it had to be internet-facing, as it turned out. Well, the developer hadn't really considered that this was meant to be internet-facing. So we ended up putting some workarounds in place, a proxy in front, and make sure that we keep the pesky hackers away from it. But last but not least, it passed all the test cases, and it never really reliably worked in practice. So it was mostly scrapped, partially rewritten, and this time we followed DevOps principles again. But having said that, there was another interesting suggestion that I received in an email from someone involved in the project who was not particularly technical. And the message read, and again I'm just going to read this: "So, since it was such a big hoo-ha to deploy it last time, why don't you just give the developer an account on the machine and he can deploy it himself?" How do I even answer this? Making ops a development team's responsibility is not really the answer. It's about working together. Because DevOps is a culture. It's not a team, it's not automation, it's not a new job role, and it's not a set of tools. Yes, you're going to need all of that. You're going to need a team to do DevOps. You're going to need automation to do DevOps. You might even need some new job roles to help you create that culture across your organization. And you're probably also going to need some new tools. But DevOps is a culture of collaboration. It's about shared responsibility. Everyone shares in wins and failures, working towards the same goals. It's about transparency, being open and ready with information, making information available when it's needed, and not holding back on that, communicating. It's about cross-pollination of teams. It's about building empathy to a certain extent. Not thinking, oh, it's not my problem, it's somebody else's problem. No, it's our problem. We all understand that there is a problem, so let's try and resolve it together. And it's also about effective communication, talking to one another. And that's it. We now know what DevOps is and what it isn't. We have seen a great example of something that isn't DevOps. And we now understand that implementing DevOps in an organization often requires a substantial culture shift. So now that we've done that, Nigel will now take you through DevOps from more of a tool and automation focus, and how tools can foster this collaboration and togetherness. Thank you.
Hello and welcome to part 2 of Clearvision's DevOps 101 series. My name's Nigel Budd. In the first part of the series, Matt introduced us to DevOps culture. In this second part, I'm going to talk more about the practices and the tools. And it's these three pillars, the culture, the practices and the tools working together that helps organizations develop highly efficient teams who can release regularly and safely. I'm going to return back to Matt's presentation again and talk about the 3 ways once more. This is from the book, The Phoenix Project by Gene Kim. We'll start with the workflow. This for me is about the visibility across the organization. You need to first visualize where your work is so you can spot bottlenecks, so you can spot people taking on too much work, so you can spot inefficiencies. And once you've identified where your bottlenecks are, you can start tackling them one at a time in order to get more efficiency out of your teams. This is vital. But first you have to find ways of tracking the work across your organization as well. So let's talk about how we can use tools to help you achieve that. Now we're going to talk mostly about the Atlassian tool stack in this presentation, but we'll talk about some of the other tools that might be useful later. Now this figure of 8 symbol, I like to think of this as like a kid's racetrack toys, where you have little motorized cars running around a racetrack. The faster you can get the car running around the racetrack, the easier it is to win. And each of those cars, as they do a circuit, represents an issue of work being completed. It might be fixing a bug or introducing a feature into the product. It doesn't matter. The principle's the same. Now it starts off with the top left-hand side with planning. Once it's been planned, it can then be built by the developers. This is where the coding's done. Once the coding's finished, you bring in the work from multiple developers, integrate it together using a build tool such as Bamboo, and then deploy. Once it's deployed, we now need to operate it. This is where your operations team come in. The operations team and others gather feedback. This feedback is then fed into the planning for the next iteration. And it's this continuous incremental addition of features and value into the product that helps DevOps release regularly and bring value to your customers faster. All of the tools around the outside of the figure of 8 are by Atlassian, as I mentioned before, and I'm going to talk through these one at a time and explain how they're used. We'll start with Confluence. Confluence, as many of you know, is the wiki tool from Atlassian. Very easy to use, very powerful. And quite often it's used to gather requirements. So this is an example of a page where someone's gathering some requirements together, and once they've gathered it through as a document in a very easy to work manage format, a document, they can start sharing and they can start collaborating. By pressing the share button on the top right hand side, you can invite people in to come and critique and comment on your document. You can start inviting people like the operations team, the testers, customers even, into this document. Working on a document at this stage is cheap. It's only word process documents. We haven't invested time developing it, testing it, releasing it, those sorts of things. So this is the cheapest part of the process where we can make easy, fluid changes to things. Once you've got feedback, people are invited to come and comment on it, edit it within place. You can start refining it. Once you've created that, we can then push some of the features into Jira as requirements, which takes us to the next page. Within Jira, we have a backlog of work, shown on this page here. The backlog is an ordered list of all of the jobs that need to be done in order to achieve your product. It's ordered so the highest priority item is at the top of the list, and that should be the one where developers start taking the work from next. Everyone has visibility of this backlog. That way people can comment on it. People can see what's coming at them in the next couple of weeks or even days. The operations team can look at this. The testers can look at it. Everyone gets to see this and comment on it. You can start getting efficiencies by the fact that you're making this efficient. So, for example, people can comment on the fact that if you combine 2 of the items further on down in the list with an item higher up in the list, you could get some efficiency because you're working perhaps in the same area of code or making similar changes. It's those sort of efficiencies that can make a huge difference to your effectiveness of your development team with very little expense. The backlog is generally controlled by the product owner in an agile environment. He's responsible for the priority order of everything. But it's important that everything goes in here. Technical debt, bugs, everything. So everyone has a clear picture of all of the work items that need to be done in the future. Jira also is responsible for showing us the workflow. using tools such as the Kanban board here, or the Scrum board. This highlights work, who is owning it at any particular time, and where it is in the process. It's very easy to spot bottlenecks from this view as well. If there are multiple items in any of the columns, that's likely to be a bottleneck. And you can actually configure Jira to stop bottlenecks building up by controlling the work in progress limit, which is a standard feature of most Kanban boards. This is where we visualize the flow of work. Everything on the left-hand side hasn't been started, everything on the right-hand side has been finished. And it's the team's duty to make things go from the left to the right as quickly as possible. And high-performing teams will work on one item at a time, concentrating their efforts to achieve the highest priority item at all times. Jira is also used to manage releases. If you're not doing continuous releasing, you want to batch up your work into small as releases as possible, but Jira is fabulous at communicating which items are going to be bundled up into which releases, how you're progressing, what your target dates are, that sort of thing. Next, move on to Bitbucket. Bitbucket's Atlassian's version control system based on Git. Git is a very popular version control system for agile teams. It encourages branching and safely modifications of code, regular merging to stop horrendous merges happening. It integrates very well with Jira. So, for example, on the left-hand side, we have a create branch button, which enables us to create a branch from within Jira. It gives us a consistent naming convention. It makes it very quick and easy for the developers to do. And it communicates in a consistent way what the purpose of the branch is. For example, the branch shown on the right-hand side is going to be a bug fix. It references the Jira reference number and includes the summary, so you get an idea of what this change is about. By linking the version control system to the issue tracking system, Jira, you get a linking between why we're doing the work, represented by the ticket, and the changes that were affected in order to make the change, i.e. the code changes within Bitbucket. You get that traceability. It's all part of the story of transparency and traceability. Bitbucket also holds code from the operations team. DevOps staff often use a process called configuration as code, where they write scripts which generate the infrastructure using tools such as Chef and Ansible, Puppet, those sorts of tools. They then store that code within Bitbucket as well. This is more about transparency. All of the teams can see all of the changes that each other are making at any particular time. Every high-performing team has a build server. Bamboo is Atlassian's one. Other examples are Jenkins, TeamCity. This is used to bring in all the changes from multiple developers and to build them on a consistent platform, a build server it's quite often called. Bamboo can also run automated tests at this time to make sure that it's achieved a certain level of quality, and then can deploy this code either into test or into production. This makes it very efficient to do the testing because it's not manual, it's all automatic. A lot of DevOps focuses on automation and making the teams as automated and as efficient as possible. But also the deployment. If you can make it what's called a one-touch deployment, where you press one button and it creates an environment, deploys the software to it automatically, you reduce the risk of failures. You make it as efficient as possible, as repeatable as possible. And the sorts of pushing out into deployment that you do are practiced hundreds and hundreds of times before they're actually done for live through each and every incremental change, making it as reliable and quick as possible. HipChat's used to collaborate amongst the team. Collaboration is important. Things are going to be moving fast in the DevOps world, with changes happening rapidly, sometimes even multiple changes a day. So it's important that everybody in the team understands what's going on. HipChat's an excellent tool for that because it integrates with the rest of the Atlassian tools so well. If you have a look on the screen, there's a red highlighted bar. This is indicating that one of the Bamboo builds has failed. At this point, the team should really swarm together and try and fix that before anything else happens, because at this point, they haven't got a working build. And if they make any more changes, they're just going to make the matter more complicated. So it's best to fix this before moving on. Highlighting problems is very important for the team. There's some positive news on here as well. For example, there's a build at the bottom that's passed some automatic tests. But it's all about collaborating. And if you have multiple teams, such as the operations team and the development team, it's important that they're working closely together, especially if they're not necessarily based in the same building. They might even be on different continents. Using tools such as chat and instant messaging helps fix some of those collaboration problems. And finally, we've gone all the way around the racetrack and we're back to Confluence. Confluence now is going to be used to do some documentation, perhaps some development documentation after the last release, perhaps a retrospective minutes, anything that's relevant to the team as well, such as, for example, a team space might have information about who the people in the team are, what their hobbies are even, what releases are coming up in the future. Any kind of discussion that helps bring the team together, to collaborate together, to encourage them to know each other, that can all be pushed into Confluence. Things like knowledge-based articles are also often created by the teams and then shared with the operations teams, the support teams, just to make sure that you're sharing as much information as possible and it's easy to find, it's easy to search for. Here's a picture containing a load of other tools. I did mention earlier that it's not just Atlassian tools you're going to need. There are hundreds of tools that can help DevOps teams work. We've got tools here for creating infrastructure that I mentioned earlier. We've got tools for monitoring. We've got collaboration tools. We've got documentation tools, other sorts of build servers. You're not going to need all of these, don't worry, but you are going to need some of these in order to help you do your job. And companies such as Clearvision can help you with advice about which are the best tools to suit your particular requirements. But there are a lot to choose from, and this is a very fluid market at the moment, with new tools coming all of the time. Let's talk about the second way now, amplifying feedback. In the figure of 8 loop, you mentioned that you need feedback. And it's important to get that feedback into the developers as quickly as possible. That way, they can make use of it and they can learn and plan what to do next based on the feedback. There are so many software products that are being released, even today, where they're producing features that the customers don't want. And it's important that we're investing money and time into adding features to a product, that we're doing it the valuable features. And the only way you can work out if features are valuable is by receiving feedback and making use of it. So let's talk about some tips here. The main tip is to involve the support team. Quite often the support teams are separate from the development teams. They're really reacting to the customer bugs and problems that the customers are facing, but they're not collaborating well with the development team. So it's important to have combined platforms where developers and the service desk team can collaborate on the same platforms and have visibility from each other's work. That way, the service desk people can know what products and features are being released in the future, and the developers can see the sorts of problems that the customers are facing and use that as part of the feedback for their learning. On the right-hand side, I've got some examples of automatic monitoring tools. Tools that look at log files, tools that look at the performance of applications. These tools could be capturing information automatically all of the time. And as developers push changes into production, they can start reacting to these changes by looking at the metrics and things that are being provided. So they can understand what difference this is making. Are there unexpected errors being produced? Is the new release having an unexpected impact on performance? Those kinds of things. You can also proactively ask for product feedback. This is an example of Jira. There's two prompts for feedback within Jira. One asking for positive feedback, which is the right-hand side one with the microphone, and also a report problem, which is a more specific, are you experiencing any problems? Both of these will enable tickets to be created, which will be logged, which will be visible to the developers. So we're proactively within the application going and asking for feedback. You can also do some other sorts of proactive feedbacks. You can push out a questionnaire. You can email the customer if you know their email address, asking for things like NPS scores, star ratings, anything that helps get feedback. If someone starts using a new feature in a mobile phone application, for example, quite often you get a questionnaire pop up and say, oh, tell me what you think of this new feature, for example. On the right-hand side, I've got an example of a dashboard. These are ways of presenting that information so that the developers and the operations people can see them together. And quite often, if they've got developers and operations people in separate rooms, they'll be looking at the same metrics and the same sorts of feedback screens. So they've got the same idea of how the software is being used and what sort of things people are saying about it. Because it's important for both of those teams. HipChat's another excellent way of handling feedback. Some teams link their HipChat into social media. So if someone tweets that they like a new feature or don't like a new feature or something like that, that can be fed straight into the chat stream. So your chat stream really becomes a feedback loop about what your customers are saying, as well as what the teams are saying to each other. Very powerful. We've spent quite a bit of time in the first two ways of making life better for the developers, improving efficiency through automation, using feedback so that we are more effective. So we're spending our time developing features that are useful and being used by our customers. This should give the developers more spare time. They're not putting out fires so much anymore. And what we can use that time for is experimenting. And now what we're trying to do is develop an organization, a culture of learning within our organization, where we can out-experiment our competition, where we can get a competitive edge so we can start beating our competition. This is what the third way is all about. And we can start using things like A and B testing as a practice, where we push out slight variations to the code onto a sample set of servers, for example, and then monitor those. And we can see how well those customers who are using the B variation in this example are using it, whether they've got different feedback, whether there's any impact to performance. By doing this sort of testing, we de-risk our releases because we're only releasing them to a small subset of customers, and we can use this control set to get some very precise feedback on how the releases are going. And because we've automated things like the releases, because we're using techniques such as feature switching, where we can switch on and off features very, very quickly, we can do these very cheaply, very quickly. And if, say, the B variation started causing problems, using the feature switching principle, we can turn off the feature so it's not affecting those customers anymore very quickly without hardly any impact to our customers. We can spend time doing spikes, hackathons. Spikes are researches that developers can do in order to learn about something. Perhaps look at a new framework, a new development technique, a new add-on or something like that that can go and help their product, or even some sort of improvements to their own processes. Hackathons are a couple of days set aside for developers to go and experiment with something. It might be a hobby, it might be an interest, it might be something completely unrelated to the product that's being developed. Because when we're developing continually and releasing continually, it can be very hard work and demanding for the developers because they're constantly at full speed. So sometimes introducing periods of calm and quiet where you're taking the foot off the pedal just for a couple of days can help the developers. It can also help encourage the innovation and risk-taking principles. That's very important. So just make sure you have some time for these. You can start doing techniques such as ChatOps. ChatOps extends the chats that we're doing with HipChat and other text messaging applications earlier, where we have a bot that listens into the chats, which we can instruct the bot to do things. For example, you could instruct the bot to release a piece of code, or to message someone, or to raise an alarm, or something like that. The bots become a member of the team, a valued member of the team. They can run automations, they can start highlighting problems. And it's these sort of fun and helpful tools that start making your teams more and more effective and efficient. So develop these sort of tools in order to be more efficient with your releases. You can also do things like starting causing chaos. The Chaos Monkey shown here is from Netflix. And it's an automatic tool that goes around the network, disrupting it. Netflix has to be up all the time. It has to be performing well. If it's not, customers will start leaving it and going to other providers. So it's important that when people go to the website, it works. And in order to strengthen their own network, they try and disrupt it. They try and break it. So the Chaos Monkey will do things like cause network storms, buffer up lots of memory. It stops processes randomly. And it tests continually the Netflix platform's ability to recover and spot problems. And this little process runs all the time throughout working hours just to cause problems that then they can sort of fix. And it strengthens and strengthens and strengthens all the time. Almost at the end now, just going to remind you about the three practice pillars I spoke about right at the start of the talk. The first of all is the culture. It's very important, as Matt said, that we build a culture where the developers and the operations team are working well together. Then there's the practices, things like automation testing, configuration as code, A and B testing. All of these practices make your teams more efficient and effective. And finally, there's the tools, like the Atlassian stack, like the Puppets, Chefs, and other tools like that. These help bring visibility to the work. These help the teams collaborate together. They're a vital part but it's all three of these things have to work together in order to achieve DevOps. Hope you've enjoyed the talk. Thank you very much.
Thank you, Nigel. So we're going to a quick Q&A session here now. Judging by some of the questions, I believe that people found it hard to find the Q&A field to enter your question. So if you look at your screen, on the right there's a little box where it says chat, people, poll, Q&A, and handouts. If you click on Q&A, you can go to the bottom, ask your question, and submit it. So we've had a few questions come in. The first one is, what was the name of the DevOps book recommended by Matt? So the name of the book is The Phoenix Project, like Phoenix, Arizona, or Phoenix from the Ashes, and which is probably what it's based on. It's The Phoenix Project by Gene Kim and others. I think there's a few co-authors on that book. I will have a chat with our events team who can probably send out the link via email afterwards. And yes, Hannah is already taking a note. So question number 2, let me just bring that up. Could you elaborate on how tools help with continuous experimentation in particular? And I'm going to let Nigel answer that one.
Okay, thank you, Matt. So there's a couple of ways. So let's start with Git first of all. So Git enables you to take a quick and easy clone or fork of the code that's currently in production and lets you experiment. So you can have your own private copy of the code that you then start adapting and changing. And if the changes don't work out, it's very quick and easy to remove them from the project without causing any harm. So the version control bit is absolutely fundamental, and this is why, or one of the reasons why Git is so popular amongst developers, is that it allows this freedom of experimentation. The next way is, of course, things like continuous integration, automated testing, continuous deployment, and automated deployment. Because it's now cheap and easy and quick to build, to test, to deploy, it's not costing any overhead through manual testing or expensive creation of environments and deployment time. The people impact on these experiments is quite low. If you combine that then with things like I mentioned, the A and B testing, the feature switches, techniques like that mean you can introduce into production experiments, get immediate feedback because you've got closely monitoring, you're monitoring logs, you're monitoring the performance, you're monitoring feedback from the customers. So you're getting that feedback from your experiments, which is the really important thing to say, are we experimenting in the right direction? Okay.
Excellent. Thank you, Nigel. So question number 2. You gave us an example of something, I guess. You gave us an example of something where DevOps failed in an organization that understands DevOps. How could this have been prevented? And did the senior manager who dropped this on your desk get fired? Right. Okay. Let's start with that last bit. No, he didn't get fired. Because to be honest, yes, we worked well together as Dev and Ops. What we didn't do is we didn't tell everybody in the organization. We should have been shouting from the rooftops, we do DevOps, and this is what it means to everybody. The janitor, the cleaners, everybody needs to know that we're doing DevOps, because otherwise you can fall into this trap. So you have to basically make sure that you spread the message and that everybody knows, because otherwise these things happen and you make these mistakes. And I hope that answers that question. Right, so we have another one here. Could you explain a bit more what Atlassian Bamboo does and how this relates to DevOps? I'm going to pass them on to Nigel, is that okay?
Okay, so Bamboo is the continuous integration tool. And continuous integration, I did have it in my figure of 8, is where you automatically build the product and you build it on a central server or machine so that you've got a consistent build, and you can also control what's on that. So the libraries that have been deployed to it, the build tools, everything that produces the product will be consistent because it all comes from the same place. So it immediately removes a common issue with development teams where developer A builds something on his machine, it gets deployed, it has a certain failure or condition. Developer B builds the same code, but it might have a subtly different library or something installed on it, and it has
a different set of characteristics, and it's incredibly difficult to sort those out because it takes a lot of digging to find out the root cause of the problem. It's not code related, it's something else. It also does the automation of the testing, running tests against the outputs, producing test results very quickly, very efficiently. It's a fantastic tool because it can run tests in parallel, or some of the plans in parallel, which means you can run them fast as long as you've got enough build agents to run the code and the tests in parallel. It'll give you very rapid feedback. Rapid feedback is, of course, important to developers. They need to know whether the changes they've pushed into the repository have worked, and whether the quality of the product is still there, or if some change they've introduced has broken something. And finally, its third feature is deployment. It's the automatic deployment of the product through a sort of one button push deployment technique, which means that you don't have expensive weekends spent deploying the software and testing it. You're actually pushing it automatically into a test environment, into a production environment. And if you're doing continuous integration and deployment well, you'll be pushing these changes into like test instances multiple times throughout the course of the development, which means it's been tried lots of times. So when you finally push it into a production environment, you've got really good confidence that it's going to work because it's done so lots and lots of times before.
Thank you, Nigel. Okay, next question. It's often said you need to create new roles to implement DevOps. What kind of roles? I think Nigel and I probably can cover this together. Shall I start? I'll just start. So, you know, I mentioned in my little talk that DevOps is not a new job role, because DevOps is about culture. But when you're trying to sort of create that culture across the business, you might need new roles that cover, you know, that allow you to help push the message, to create that culture within the different teams, create those communication channels, and also so that's on an organizational level. And there are other roles such as DevOps automation engineers, because these are cross-functional skills where you need people who are good with you know, automation like continuous integration that Nigel just mentioned, but also who understand how to automate things with Chef and OpsWorks and Amazon AWS, etc. You know, those automation technologies about, again, this came up in Nigel's talk, you know, infrastructure as code, you mentioned. You know, these sort of things are specialist roles, and you need people who understand both sides, who have that AWS view, if AWS is your target platform, and still have the continuous integration view. And have I covered all of this, all here? Nigel, is there anything else you can think of?
Yeah, I think there's quite often a temptation to create DevOps engineers, and in some ways there's a danger of creating another silo, because rather than just having developers and operations, you've now got DevOps as well as developers and operations, three silos rather than two. So for me, it's all about culture, not naming of roles. It's not the job title that you give someone, it's their ability to adapt, to learn, to experiment, to change, to see both sides. It's all about culture.
So yeah, so we totally agree here. It's about creating that culture, and then, you know, within your, you know, when you're ready and you've created that culture, then yeah, there will be probably a need for new job roles. But the key is the culture, and the job roles are not going to create it. That's what you're saying, essentially, isn't it? Yes.
Yeah.
Right. I think we've got time for one more. Yeah, I'm just looking at Hannah. Yeah, we've got time for one more. Are DevOps principles unsuited to any particular kind of business or size of business? Are there any situations you would advise going slow and picking only certain aspects of the practices? Right, that's a really difficult question.
It's a really good question.
It's a good question. It's a great question, but yeah, go on then.
So where I see people struggling with DevOps is with legacy applications. So you know, I've got a 10 or 12-year-old application, something like that. Chances are you've not built this with test automation in mind. It might be using legacy languages and technologies that make it difficult to automate the testing of, in which case you're going to struggle to get that continual testing, continual feedback, things like that. It doesn't mean you shouldn't try. It doesn't mean there isn't value in trying to get your operations people deploying faster. And a lot of the things we've spoken about in this webinar are still relevant and you can take advantage of, but it will struggle and it'll take a long time to get where you want to be.
Excellent. Thank you, Nigel. Right, I think we're out of time. Is that right? So Hannah has asked me to remind everybody that there's more webinars coming up this year. Next year. Good point. Good point. We are at the end of the year, and we'll be sending out more information by email and also watch our blogs. But thank you very much, everyone, for attending, and I hope you enjoyed the session. Thank you very much.
Thank you.